Welcome to this lesson where we're going to look at two-way tables. Now, two-way tables are essentially a different way of representing the information found in a Venn diagram in a table. And both of them is important for different reasons. A Venn diagram is very visual. You look at it and you understand what's happening. A two-way table, however, has information which is helpful when we're looking at probabilities. So here we have the exact same information represented in a Venn diagram and in a two-way table. You'll notice here that we have the female, this circle is female, so not in that circle is going to be not female or male. So we have female and male. Then the other circle is going to be the other column or row. So here we have our left-handed. So if you're in that circle, you're left-handed. If you're outside, you're right-handed. So you have left and right-handed. And now these numbers just correspond to where they are on here. We're going to look at how we would convert in the next video, but for now we're just going to leave it as that. Now the numbers here are actually the sums of each of the rows and columns. So here we get the total number of females. So 7 plus 46 in this column, all that's females, so it's 56 females. Here we have 5 and 63 males, which comes to 68. Again, we have the left-handed, so 7 plus 5 people left-handed, so we get 12, and right-handed, we have 109 right-handed people. And this one here is just, if we were to add up everyone, so it's all of the males and females gives us 121 people, or all of the left-handed people plus all of the right-handed people gives us the total number of people. So you only add up one way, you don't add up both of them. These numbers come in handy for questions when we are working out, say, what's the probability that if someone was right-handed, they would also be male. So what's the probability that if someone is, we'll just go RH for saving time, if they're right-handed, they are male. Now in this situation, we forget about everything except for the right-handed column. Now, if we were to do that from here, we could do it. The probability that they're right-handed would be, and they're male, would be this number here, because they're not female and they're not left-handed, so it's 63. So we put 63 over, and then if they're right-handed. So our sample space only includes right-handed people. So we can't include these two numbers, it's going to be 46 plus 63. So we're going to get this. And then we can simplify that and we get the right answer. However, if we have a two-way table, we already have this number there for us. So we would look, if someone is right-handed, so we look at right-handed, there's 109 right-handed people. So we can already put the sample space, or the size of the sample space down there. Then we keep reading, they are also male. So we're looking in here, if they're right-handed, they're also male. So we put a 63 on the top. And that would give us the answer there. So it's very easy to work out. Here we have a two-way table, we're going to quickly fill it out. So we've got whether someone is a child or an adult and whether they play or don't play sport. So again, we just add up the numbers through here. So 20 plus 4 is going to be 24 people who play a sport. Doesn't matter if they're a child or an adult there. Along here we have 26 people who don't play a sport. Again, children we have 25 children, and adults we have 25. So we just add up 4 plus 21 gives us 25, 20 plus 5 is 25. Now to get our final number, we add these two up and get 50, and we can check if we have these two on that we get the same number. And we get 50, that's what we want. If we were finding what's the probability that one of these people chosen randomly is a child and plays sport, so P of child and plays sport, we can just quickly look at it. We see child that plays sport, there's 20 favorable outcomes over a total of, this number is our total, 50. So we don't have this situation here where if there's something, then we do this. We just go for our 20 over 50. I would like you to find out what's the probability that if someone is, what's the probability that someone chosen randomly would be an adult who plays sport. Okay, so if they're an adult and they play sport, they're going to be this part here. So we go 4, and then over our total of 50, because we're choosing out of everyone. I hope that lesson's made sense to you. Please do bring me any questions if you have them. Thank you.